Two lines are said to be perpendicular if they meet at right angles to one another. So let's say if one line is moving, is like this, and another line is like this, and then these two lines meet at and make an angle of 90 with each other, then we say that these two lines are perpendicular to each other. So if this is the line AB, and then we also have a line CD, and the two lines meet and make an angle of 90 when they meet, we say that they are perpendicular. So mathematically, remember each of these lines has a gradient. So if the gradient or the slope of this line is M1 and the slope of the line CD is M2, the two lines also, if you multiply the product of their gradients, we get an answer of -1. So two lines are perpendicular if the product of their gradients, that is M1 multiplied by M2, is equivalent to -1. So if you multiply their individual gradients together, you get an answer of -1. Then we conclude that those two lines are perpendicular. So in this case, we've considered lines L1 and L2, and if their gradients are M1 and M2 respectively, then if L1 is perpendicular to L2, then the product of their gradients, that is M1 multiplied by M2, should be able to give an answer of -1. Okay, so we have an example here. We are given 3 points, that is point A, point C, and point D. Prove that the line SC is perpendicular to the line CD. So to prove this, we have to find the gradient of the line SC, and we also find the gradient of the line CD. So if we multiply the two and we get an answer of -1, then it means that the two lines, that is SC and CD, are perpendicular to each other. Okay, so let's try out that. So if we try out that, so let's start by finding the gradient of the line, SC. So SC connects point A and point C. So its gradient, so the gradient for SC will be given by Y2, which is -7, minus Y1, which is 4, divided by X2, which is 5, minus X1, which is 2. Okay, so -7 minus 4. Since we are subtracting a negative from a negative, that means the negative value increases and this becomes -11. -11. And 5 minus 2 gives us 3. So we end up getting -11 divided by 3. Okay, so let's find the gradient of CD. CD connects point C and point D. So its gradient will be given by Y2, which is 5, minus Y1. Y2 minus Y1, 5 minus -7, divided by 19. 19 minus 5. 19 minus 5. So we end up having our answer as 5 minus 7. That is the same as 5 plus 7, which is 12. Then 19 minus 5 gives us, 19 minus 5 gives us 14. So if we try to reduce this, we shall end up having, if we reduce it by a factor of 2, we shall end up having 6 out of 7. So if we call this gradient M1, the one for SC, and the gradient of CD M2, so let's see what we get when we multiply M1 times M2. So M1 times M2 will give us negative 11 out of 3 being multiplied by 6 out of 7. So when we multiply these, we end up having our answer as, when we multiply this, we end up having our answer as negative 11 times 6. First of all, we shall reduce this 3 with this 6, and we end up getting negative 22 out of 7 as our answer. So you realize that this is not, this is the answer we get is negative 22 out of 7. So if we had to put this in fraction form, it is around negative 3.14, which is not equivalent to negative 1. So therefore, we conclude that since the product of M1 multiplied by M2, since it is not equal to negative 1, then SC and CD are not parallel, are not perpendicular, sorry, they are not perpendicular to each other. They are not perpendicular to each other because the product of their gradients is not equivalent to negative